two blocks of mass M1 and M2. M1 is 1.3 kg and M2 is 2.8 kg. They're passed over a frictionless pulley via a cord. So we need to find what is the tension in the cord and what is the acceleration of the mass. So the two mass, they have different the value of mass is different, so there will be an acceleration, and this acceleration in this side will be downwards, A, and for mass M1 it will be upwards, A, because M2 is greater than M1, as we can see. And tension here, so we will write tension equation first for M1, and that will be, since tension in the cord is upwards and weight of due to the mass is downwards but acceleration is upwards, so that will be T minus M1G will be equal to M1A. That will be for mass M1, and for mass M2 the acceleration is downwards. So for M2, what's happening, weight M2G is downwards, acceleration is downwards, and tension is in the cord is upwards. So M2G for this case will be M2G minus T will be M2A. So this will be our equation 2, let's say, and this one is equation 1. So if we add these two equations, what happens, T gets cancelled because here T is positive and here T is negative. So we have M2G minus M1G, so equals to M1A plus M2A. So this is becoming A equals to M1 plus M2 M2G minus M1G. Now we know the values of M1 and M2. M2 is, I don't know, 2.8 and 1.3. 2.8 kg and M1 is 1.3. So the difference is 1.5. So once we plug in those values, we get A to be 3.6 meter per second square. So that we can get. We can just plug in these values here. M1 is 1.3, M2 is 2.8, and of course G is gravitational acceleration, so that's 9.8 meter per second square. So that's there, and then from that we can find T minus M1G equals to M1A. So T equals to M1 G plus A. If we do that, we get T1 is approximately 17.4 Newton. So please double check the calculations, but this will be the procedure for solving the problem. So we have two masses of different values pass through a frictionless pulley, and then we will have an acceleration, and this is how the acceleration we can find, and the tension in the cord we can find.